Hello. In this video, we're going to continue working with logarithms and equations, but in a slightly different way. Instead of taking logarithms and applying them to equations, we're going to start with equations that already have logarithms on them. So for example, this equation is log 2x plus 1 equals log 3x minus 5. So if you notice, we already have a log. We don't have to put logs on the equation or convert to logarithmic form. We have a log and we have to do something about it. And in particular, we would like to just say 2x plus 1 equals 3x minus 5. This is very similar to if we had 7 to the 2x plus 1 equals 7 to the 3x minus 5. What we would do is we would drop the base, or you could think about it as equating the exponents. Because the only way for 7 to the something to equal to 7 to the something else is if those two somethings were equal to each other. And this is also true with logarithms. The only way log of 2x plus 1 could ever be equal to log of 3x minus 5 would be if 2x plus 1 was equal to 3x plus 5. From here, we subtract 2x from both sides. We add 5 to both sides. 6 equals x, and we're done. Although, we do have to be a little careful. So the step we're doing here is we are equating the argument. The thing inside is often called the argument. And what we have to be careful of is that the number we arrived at is legit. Because there's all sorts of numbers that you can't put into logarithms, and this might be one of them. So we should just check it real quick. Log of 2 times 6 plus 1 and log of 3 times 6 minus 5. That would give log of 13, which would be a little bit more than 1 because log base 10 of 10 would be 1 using benchmarks. And this would give you log of 18 minus 5, also 13. So if you notice, these are the same, and log of 13, this is legit. We are allowed to do log of 13. So this checks out. But you'll see in the next example that it doesn't always work that way, and so it's important to check your answer. All right, we've got log x plus log x minus 1 equals log of 6x. Now right away, you might say, oh, drop the logs. We just got x plus x minus 1 equals 6x. But this is very similar to when we were doing exponents. If I had 7 to the x, and then 7 to the x minus 1 or something, and then 7 to the 6x, it's not really fair to just drop the 7s, because there's two 7s on one side, there's one 7 on the other side. You're supposed to get it all combined into a single 7. Just one 7 here, one 7 here, with some stuff here, some other stuff here, and then you drop the 7s. Here, we have sort of the same problem. We have a log and a log. We can't drop 2 logs on one side and 1 log on the other side. It has to be log of stuff, log of other stuff. So, is there a way to combine those logs? I think there is. Log rules tell us we'll get log of x times x minus 1 equals log of 6x. Well, there we go. We got a log on each side. We can drop the logs or equate the arguments. Then we can expand this as x squared minus x equals 6x. Kick that to the other side, so x squared minus 7x equals 0. Remember, we're solving a quadratic here, so we have to factor. Get the x out, and so you get x equals 0 and x equals 7. And it'd be tempting, right, to just box our answers and call it a day, but I did warn you, we should check. So let's check x equals 7. Let's check x equals 7 over here. Now to do that, we go back to our original equation all the way back to the very top. No simplification allowed. Very, very top. We get log 7 plus log of 7 minus 1, so 6. And the other side should be log of 6 times 7, so 42. Now you can try that on a calculator if you want, or you can just kind of look at it and say, yeah, log 6, log 7, I mean, we could combine this. This will be log 42. Log 42 equals log 42. Yeah, no problem. No problem. Everything checks out. But what about the x equals 0? Well, here I'm going to get log 0 plus log negative 1. And then on the other side, I'm going to get log of 0. Well, this is a mess because log of 0, this right here, is undefined. But worse than that, log of negative 1 is also undefined. And 0 is undefined, like log of 0. So we have all three terms being undefined because you can't take the log of 0 and you can't take the log of any negative numbers. So while the algebra says, hey, x equals 0 is a solution, it's more like x equals 0 is a solution of the algebra here, not of the original log equation. And so we have to reject the x equals 0 because it's not in the domain or because it makes the log negative, or it just doesn't work, however you want to think about it. All right, so go ahead and pause the video, give this one a try, and remember to check your solution to make sure it doesn't give you a negative or a 0 in the log. All right, assuming you gave it a try on that left-hand side, we've got base 3, we can use our log rule, so x plus 6 times 10, and we get a 3. Now you've got two choices here. You could either drop the logs, or you can convert to exponential form. I'm going to show you exponential form first because I think it's kind of a nice conversion. The reason why we can't drop the logs is there's not logs on both sides. There's only a log on a single side. So if I was to do something totally wild, I could convert to exponential form. The base becomes the base, so I'll put that over here, 3. And then I get power 3 equals x plus 6 times 10. 3 cubed is 27. This is 10x plus 60. Move the 60 over, negative 33 equals 10x. Divide by 10 and x equals negative 33 over 10. Okay, and then we should check it. And when we check it, we only have one place to plug the x in. So you have log base 3 of negative 33 over 10 plus 6. Now you might be tempted to think, oh, that negative, it's going to be a problem. But if you look here, when you plug in the negative number, negative 33 over 10 is like negative 3.3. And when you add 6 to that, you have a positive number. This is a positive number. And so it's okay. It's log of some positive number plus some other log. It works out. This is good. How would I do this if I was talking about the log method where we drop the logs? Well, I would need to take that 3 and I would need to rewrite it as a log of the same base. This is a little bit of guess and check. Log base 3 of 3, is that 3? No, that's 1. Log base 3 of 9, is that 1? No, that's going to be 2. Log base 3 of 27, that will be 3. So I rewrite the whole number in terms of a logarithm so that I've got two logs. Right, let me write it out nice and clear. We've got log 3 of 10x plus 60 equals log 3 of 27. Now I've got log on both sides. I drop the logs. And then I proceed just like before. Negative 33, x equals negative 33 over 10. Which method is better? It doesn't really matter. You can do the convert to exponential. You can do make everything a log and drop the log. It doesn't matter to me. If you're really wanting to pick a method and say which one is like the absolute best, I mean, I do kind of like this one. This is my preference. But just know both. You know, try one, try the other one. It's good to have multiple methods when you're doing questions, just in case one method doesn't feel like it's working the smoothest. You can always switch to the other one. All right, let's go ahead and try another one. We've got log x plus log x minus 3 equals 1. So that's going to give me log x times x minus 3 equals 1. But we should rewrite that 1 in terms of a log. This is base 10, so that's going to be log base 10 of 10. All right, so we got a log on both sides. We can equate the arguments or drop the logs. And now we're into algebra land. So we have a quadratic. Kick everything to the left-hand side. Factor it out. Two numbers are multiplied to give negative 10. Negative 5 plus 2. X equals 5. X equals negative 2. Okay. Well, we should check them both before I box them. And if I was to check, if I check the 5, I get a log 5 and I get a log of 2. 5 minus 3 is 2. Okay, that seems fine. If I check the x equals negative 2, I get a log negative 2. Oh, stop right there. I mean, I don't even need to plug it into the other term to know that this is rejected. Log of a negative number is undefined. As soon as you have even one problem, the whole thing is toast and you can reject that number. All right, we got one more here. Go ahead and pause the video and give it a try. Okay, log x plus 2. The minus means we need to divide it. And then we've got this silly thing. Now notice here, we've got a log on both sides. So it feels like we could drop the logs. But there's this negative sign here, and that just doesn't feel legit. What we actually need to do is take that negative sign, which is actually a negative 1, and we need to hop it up as an exponent. So this is log x plus 2 over 12 equals log of x plus 3 to the negative 1. Now we can drop the logs. So x plus 2 over 12 equals x plus 3 to the negative 1. To the power of negative 1 means we're looking at a 1 over x plus 3. And probably cross multiply. I think that's easiest. X plus 2, x plus 3 equals 12. Now we've got to FOIL everything out. So this is x squared, 3x, 2x, 6. All right, quadratic land means kick everything to the left side. So x squared plus 5x minus 6 equals 0. Two numbers that multiply, I'm thinking x minus 1, x plus 6. So x equals 1, x equals negative 6. Now we got to check. For the x equals 1, I think that one looks good. You just get log of 3 on the left side. On the right side, you'd get log of 4, it looks like. Log of like 1 plus 3. So 4. Yeah, that checks out. So that one's going to be good to go. Now, x minus 6. I'm not feeling too confident here. I'm going to get log of minus 6 plus 2, which is log of negative 4. And that's all I need to know, that this is rejected. All right, so let's go ahead and take some notes on this. So this is solving equations with logarithms already present. Right? It's like when you got an equation and there's already a log in it. So basically, you need to use your log rules, and mostly your log rules, and convert whole numbers so that in the end you have log of some stuff equals log of some other stuff. Then you equate the arguments and you get square equals triangle. From there, you do algebra, and then in the end you got to check your answer. Because, and this is again something to remember, things to remember, log of negative numbers and log of 0 are not okay. These are going to be undefined. Now, if we're looking at an example, I'm going to give you a fun one here. Let's do ln x squared minus 3 minus ln 2 equals ln of 11. Remember, ln is just log base e, so you still do the same steps. Instead of writing log, you write ln and you make it happen. All right, assuming you gave this a try, we get ln of x squared minus 3 divided by 2 equals ln of 11. We have logs on both sides, so we can equate the arguments. Go ahead and cross multiply up that 2. Let's move that 22 over. Factor time, this is a difference of squares, x minus 5, x plus 5. So x equals 5, x equals minus 5. Now you might be tempted to go, oh, I know, logs can't do that negative, take the positive, boom. But that would be incorrect and a bit hasty. Let's go ahead and check. If we check x equals 5, we get ln of 5 squared minus 3, which is ln of 25 minus 3, so 22. So that checks out, which is what we expected. But let's go ahead over here and let's check x equals negative 5. Well, we'll get ln of negative 5 squared minus 3. But negative 5 squared is another positive 25. And that's still going to give you a 22 inside. You can take log of 22. It's not a negative number. And so this checks out as well. Both of these are legitimate options, and so they're both solutions. All right, for some extra practice, you can work on Unit 9, Worksheet number 6. You can give one of those a try. Hope you enjoyed this video, and as always, thanks for watching.